All right, Science is Mrs. Crane again, and here we're actually going to look at fermentation, what happens with the atoms and the chemical arrangement here. Now this is just me pulling them apart, but also to show you how the equation's balanced. So we have one molecule of glucose. Glucose actually has a few isomers, which means same number of atoms, same type of atoms, but different arrangement. Those are fructose and galactose. So different is just how the carbons are arranged in this ring structure, basically. So sugars form these nice little rings. Okay, so what happens here is in the reaction we basically break this down and it will form, we've got the structure of C6, so you can see the 6 carbons there in black. O6, which is 1, 2, 3, 4, 5, 6, and O12. If you have a look, you might be able to see 2 up here, 3. Every carbon should have 2 hydrogens on it, except for this one, which is at the end. Due to that branch there, that one has 2, that one has another one to make up for it. Okay, kind of the way I think about carbohydrates, which glucose is one, that's what sugars are, is it's for every carbon there's a water unit. So H, 2H, and 1 oxygen. That's the idea of what a carbohydrate is. There's basically a water molecule in every carbon, in effect. So what happens, we basically then get this and we break it up. Okay, so we're going to leave one of the OHs there, and on the rest of them we're going to join them. So we've got that one there. The leftover oxygens we're going to react. Another hydrogen. Let's see where I want to nick it from. Okay. So far in the making of 1 ethanol molecule, I have now got 3 oxygens on the side that need to be attached to something. Let's make my other ethanol molecule first. So let's take off that one. There's the 4th random oxygen on its own. And we have 2 extra carbons here. Let's take off their hydrogens and attach them to this last one. Has 1 hydrogen on here, the other one's already got everything, so let's add these on. There's 1, and there's 2 ethanols. Okay, those are ethanols, we're all happy, and this is what we have left over. 4 oxygens and 2 carbons. Sorry. To finish it off, we need bendy bonds to make this work. Okay, so I'm just going to remove all the single bonds on here because the bonding between oxygen and the carbons is going to be double bonds, for which we need the bendy model things. Okay, so here's 1 carbon. We'll attach our bendy bonds. Okay, 2 oxygen here, 1 on that side, 1 on the other, and the same with the other 2. Okay, so there's our 2 carbon dioxide produced here from our reaction. So one thing to notice about this reaction is it's kind of similar to what we saw with respiration, that we still produce carbon dioxide. But the reason that our carbon doesn't fully react is because there is no oxygen for that to take place. And so that's where we get, instead of getting water and carbon dioxide, we get ethanol and carbon dioxide. Not enough oxygen for all those to react fully.